Hi guys, it's Mrs. DeLoss, and we are looking at Unit 9 Skill 5 today, where we're talking about the 6 different trig functions. So our essential question is, how do we find all 6 trig functions? So in a right triangle, you'll notice that there are going to be 6 possible trig ratios. Ratios are the same thing as fractions. You learn about some of them in geometry if you've taken geometry. Some of you may not have taken geometry yet. So we're going to talk about this a little bit more in depth. We have 3 trig functions, 2 of which you are super familiar with, sine and cosine, but we're adding on this third one called tangent. And you'll notice that we'll use this symbol a lot. That is called theta. So this symbol, it starts with an O and then a line through it, is called theta. It's just a Greek letter, that's what it says here, that represents a given angle, okay? And so there's 3 sides to a triangle that you have to know. The first one is called the hypotenuse, and this is always across from the right angle. So we're going to write that, always across from the right angle. So here's our right angle, and if I go across from it, there I will find my hypotenuse. The next thing you need to know for the other 2 sides is where the given angle is. So here's our given angle. Based off of that, opposite of it is over here. So opposite is across from the given angle. And then adjacent, the last and final one, is next to. That's what adjacent means. It means next to the given angle. So one more thing I want to mention before we get into the trig functions is that if a side is missing, we can use something called the Pythagorean theorem, a squared plus b squared equals c squared, to find that third side. And one thing you have to know about this is that c is always your hypotenuse. Alright, so we're going to dive into those 6 trig functions. You are going to be using opposite, adjacent, and hypotenuse to define the ratios. So we've got 3 real trig functions, and then we use the reciprocal of those 3. The reciprocal just means to flip it. So our first trig function is called sine, but remember it's represented by sin. Don't say it as sin, it means sine. And sine is always opposite over hypotenuse. Its reciprocal, which is called cosecant, is represented by 3 letters, CSC, and it's just the flipped version, the reciprocal, hypotenuse over opposite. So far we have sine uses O over H, okay? Cosine, the next one, is represented by COS, and it uses adjacent over hypotenuse. Its reciprocal, called secant, SEC, uses hypotenuse over adjacent. So our original cosine uses A over H. Last but not least, we have this new one called tangent. Tangent is represented by 3 letters, TAN, and it uses opposite over adjacent. Cotangent, its reciprocal, represented by COT, cotangent, is adjacent over opposite. So tangent, the original, is O over A, opposite over adjacent. So this little trick here, SOHCAHTOA, if you can memorize that, then you'll have your 3 original, and then you'll just know to make the reciprocals over on this side, we just have to flip it. If you forget where these are in the calculator, if you hit the trig button, you might want to write this down. If you hit the trig button, you'll notice that you have 6 pieces here. So we've got sine first, cosine second, tangent third, and then you'll see CSC, SEC, and COT. Those are your reciprocal trig functions. And they go in the same order as these 3. So if sine is first, cosecant matches with it because it's first in that set of 3. And then second, we have cosine matching with secant. Oops, I should have drawn a 2 there. And then third, tangent matching with cotangent. Okay, so if you forget what matches with what, just hit the trig button on your calculator. There's two identities that are helpful to know but not necessarily required to know. Tangent is also equivalent to sine over cosine, and then of course its reciprocal trig function, cotangent, is just the flipped version of that. Alright, lots of info, but we're going to get you lots of practice in the next couple of pages. So in every one of these we're asked to find all 6 trig functions. So that means we're going to definitely be using so, ka, toa. Now, if you've ever had Miss Wesley or you know who she is, she often uses the phrase, some old horse caught another horse taking oats away. So if you want that phrase to help you out, it's some old horse caught another horse taking oats away. Feel free to write it down, rewind if you need to, so that you can pause and write it down again. All right, so that's just a trick for memorizing it. Personally, I just sound it out. So here we're given a triangle. I notice that it has 2 sides labeled. We've got 20 and we have 16. We have our given angle theta, but we're missing this side over here. So the first thing I'm going to do is identify the hypotenuse. I notice that it's across from the right angle, so that gets an H. And then I notice that this side is next to my theta, so that's an A for adjacent. And then across from my given angle must be O. So I've labeled O, H, and A, but again, I'm missing that green highlighted side. So my first step is to find the third side. Find third side. And we're going to do that using a squared plus b squared equals c squared. So remember that the hypotenuse always goes in for c, so 20 squared has to go on the right. And then we can just do, say, x squared for that green side, and 16 gets squared. Okay, so you find out what these are, then you have x squared plus 256 equals 400. You subtract away. X squared then equals 144. And then we square root both sides. So now we have x equals 12. So that green side that was originally unlabeled is now a 12. So our opposite side is now called 12. The second step is to find all 6 trig functions. So I'm just going to write out sine theta first, cosine theta second, tangent theta third. We'll write out all of these and then we'll get into their reciprocals. So sine uses O over H. So if I'm finding my O side, that's 12, over my H side, that's 20. So sine is just 12 over 20. If you want to reduce, you absolutely can, but it's not required unless it says to put it in simplest form. So if you want to reduce, the quick way to do it is just 12 divided by 20 right on your calculator, hit enter. Or you can divide out the common number. So cosine uses A over H. So adjacent, 16, I shouldn't have boxed over that, 16 over hypotenuse, 16 over 20. And if you reduce, that gives you 4/5. And last but not least, we have tangent. Tangent uses O over A, toa, O over A. So that would be 12 over 16. So remember, these ratios are just fractions. That's all you have to do with them is write them out. That's it. 12 over 16 reduces to 3/4. So we've got the first 3 done. The next 3 are the reciprocals. So remember that sine matches with cosecant. And then cosine matches with secant. And tangent matches with cotangent. One trick I have for this is you'll notice that the S word matches with the C word matches with the S word. So they don't match with the same letter, they match with the opposite. Alright, all we have to do is take our original sine and flip it upside down. Now it becomes 20 over 12. You don't even have to look back at the triangle because remember it's just a reciprocal, it just gets flipped. If we were using the reduced versions, they would be 5 over 3, or it would be 5 over 3 for cosecant. For secant, it becomes 20 over 16, or 5 over 4. and 16 over 12 for cotangent because, again, I just flipped the fraction upside down. That's all you have to do. And now we've got all 6. Wah! One thing I want to point out is that sometimes they don't just give you the triangle, they make you draw it. So if they say something like this, triangle ABC with measure of angle C equals 90, AB equals 20, AC equals 16, determine all 6 trig functions. I'm not going to write that part out, but say that that's what they gave you. Based on angle A. We do need that bit of information. You're going to draw your own picture. So you start by drawing a right triangle. You put your right angle in it. We know that the right angle is 90 degrees, so therefore C goes there. A and B can go in either place. It doesn't matter. Truly, does not matter. The next part says AB is 20. So if I know that I have A to B is the length of 20, then that goes right on the side. And then AC is 16. So A to C, that length must be 16. And then it says that it's based on angle A, therefore my theta would go at angle A. If it said based on angle B, my theta would go at angle B. Okay, so if you're asked to draw a triangle, you can absolutely do it on your own. It's not hard. You just have to process and think and then draw according to what it says. This next one here says, given a ratio. So it says sine of theta is 4/5 if theta terminates in quadrant 1. So there's a few things that we have to know for this. First, we have to know our quadrants. So this might be something you want to come back and highlight because you have to know where your quadrants are. They start in the upper right and they go around like a C shape. So upper right is quadrant 1, upper left quadrant 2, bottom left quadrant 3, bottom right quadrant 4. You have to memorize that. It's never given to you. The next thing you need to know is how to draw your triangles. You'll see off to the side on the left-hand side that it says don't draw your triangles like these. Always draw from the origin and connect to the x-axis. That's absolutely true. I'm going to give you an even better trick. You're going to start working on a bow tie. Okay, so we all know what bow ties look like, right? They look like this and they look pretty and you wear them when you're fancy, and now we're going to put them on a graph. So you're going to draw the bow tie. Oop. Where the middles meet right at the origin. So now your triangles will be perfect every time because you know that your right angles are here on the sides where it's the x-axis meeting your opposite side. We always have the thetas at the origin. A trick to remembering that is theta looks like a 0. It's at the origin. Origin is 0. 0, 0. And then you would just be able to label from there opposite, adjacent, and hypotenuse. I'm just going to label one triangle to give you an idea. Across from the right angle is the hypotenuse. Across from the given angle theta is your opposite. Right here along the x-axis will always be adjacent no matter what, as long as you've drawn your triangle correctly. So let's get to it. We've got quadrant 1. So that would be over here. If I need to, I can actually draw out the whole bow tie, right? You see that pattern. But I don't have to personally. I've just drawn it on the right, so I can actually just reference that. Sometimes it's nice if you can just draw it quickly and then reference it, and then redraw it for real. Right angle, theta. We are given sine is equal to 4/5. So before I can go anywhere, I have to have SOHCAHTOA in my head. SOHCAHTOA. So sine is O over H. So let's label up our triangle, and then we'll put the 4 and the 5 on there. Hypotenuse is opposite of the right angle, so that's over here. Opposite is across from the theta, so that's over here. And adjacent is always along the x-axis. So now I've got 4 on the O side and 5 on the H side according to this right here. Sine is 4/5. So we need to first find that third side. Find third side. Okay, so we've got a squared plus b squared equals c squared again. We know that the hypotenuse has to go in for the c. The 4 can go in either the a or the b spot. It does not matter. The other one we can just call x. So this is 25 here. 16 plus x squared. If I subtract, then we get x squared equals 9. And then this is interesting. We have to think about positives and negatives. When we take the square root, remember that you always get a plus and a minus. Just like in the quad formula, x equals negative b plus or minus square root. Because you could have a negative squared and becomes positive, or a positive squared and becomes positive. So when we take the square root, we also have both options. So what I have to focus on is that third piece, the one I'm looking for, in the positive direction or in the negative direction? Here it's positive because it's going to the right, so that means x equals positive 3. That gets plopped on there, and now we can find our remaining 5 trig functions. So here we've got step number 2. Sine theta was already given to us, so I'll just write it out real quick. That was 4/5. Cosine theta and tangent theta. Remember that cosine uses a over h, C/A over h. So a is 3, according to our picture, and h is 5. Tangent, TOA, O over a, 4/5. And then they're reciprocals. S matches with the C word, CSC, cosecant. Just flip it upside down, and you're good to go. Ready to rock and roll. Cosine matches with secant, the S word. And again, if you forget this, it's right in your calculator. Hit the trig button. 5/3. Tangent matches with cotangent. 5/4. And boom, you are done. So again, bow tie is going to be your best friend. You have to memorize your quadrants, and you have to think about positive and negative. Maybe we should write a note. Remember to consider plus and minus square root. Okay, flip to the next. So on this page here, they give us the same statement, find all 6 trig functions, but we're given a point on a circle. Now, really, you don't have to worry about the thing that says on a circle. What happens here is that we have something called the unit circle, and the hypotenuse is always 1. And then this point happens to be on the circle. Now this one is a negative x value and a positive y value. That's a little thing I always love to write out, negative x, positive y, because then that helps me figure out what quadrant it is in. So if I go left x, negative x, and then positive y, now I've got my triangle. Left x, positive y, right angle. So if you think about your bow tie, we just stole this triangle. Okay, so theta, always by the origin, hypotenuse across from the right angle, opposite across from theta, adjacent on the x-axis. And since this was my x value, I'm going to label that -3 square root 17, nice and ugly. And y value must be +4, we don't know the hypotenuse. So in order to find all 6 trig functions, we got to find that third side first. So find third side. A squared plus b squared equals c squared. And with this one, our hypotenuse is unknown, so that gets to be the x squared this time. On the left side, make sure that you put -3 square root 17 in parentheses, plus 4 squared. If you don't, then that negative is going to cause you issues. So that squared gives us 153, I just used the calculator for it, plus 16 equals x squared. 169 equals x squared. And then we square root, and remember the plus and minus. Now let me tell you that the hypotenuse is never negative. All right, it's a diagonal, so we're going to consider it as always a positive, so that means x is +13. So I'm going to place that on the hypotenuse side. And then we're going to list all 6 trig functions. So we have sine theta, so cosine theta, TOA, tangent theta. All right, see if you can write out SOHCAHTOA. S blank blank, C blank blank, T blank blank. So, TOA. Some old horse caught another horse, taking oats away. All right, here we go. Sine is O over H. So my O side is 4, my H side is 13. Done. Cosine is A over H. Negative 3 square root 17 over H, 13. Tangent is O over A. 4 over negative 3 square root 17. And then we're going to flip them so that we can make our reciprocal trig functions. So now we've got sine matching with cosecant, cosine matching with secant, tangent matching with cotangent. And again, all you do is literally flip the fraction upside down. And you're done. I think we have 2 more problems on the back side. We're going to get to them real quick. Similar format. 1 more question. That's it, friends. You're almost done. All right, this one says, if the terminal side of angle theta in standard position passes through the point square root 3 over 2, comma 1/2 on the unit circle, it should probably say determine all 6 trig functions. So let's fill that in. Okay, so again, that unit circle, not something you have to really memorize. The unit circle has a radius of 1. Therefore, the hypotenuse is 1. So if we were to draw in all of our right triangles with the bow tie, this point would land somewhere on the outside. Okay, all it's doing is giving us our x and y values, really. So x is positive, y is positive. Positive x, positive y. First step, draw your picture. Positive x means go to the right, positive y means go up. So what we just did was we stole the triangle in quadrant 1. Right angle and theta. So label your O, H, and A, then we'll get to labeling the numbers, and then we'll find the third side, and then the 6 trig functions. Right? It's the same process every time. Make sure you have all 3 sides, and then your trig functions. Okay, so H across from the right angle. O across from theta. A is adjacent, next to the theta. The positive x value was square root 3 over 2. We're not scared of fractions, and we're not scared of radicals, all right? No whining, no crying. The positive y value, the one that goes upward, straight up, not diagonal up, but straight up, is 1/2. And then again, we have to find that hypotenuse side. Okay, so we're looking, and we've got a squared plus b squared equals c squared, of course. And our hypotenuse is unknown, so that's the x squared in this case. We have square root 3 over 2 getting squared plus 1/2 getting squared. And again, you can type this right into your calculator. This first one will give you 0.75. The next one will give you 0.25 equals x squared. This sums to 1 equals x squared. We square root both sides, and we consider plus and minus, but it's a hypotenuse, so it's always going to be positive in this case. Square root of 1 is just 1. Didn't we just talk about that? The hypotenuse on the unit circle is 1. So if you recognize what the unit circle does for you, you would have already had that third side. Now, it's not a huge deal because we can find it using the Pythagorean theorem. That's why it's not a major issue with having to memorize the unit circle with a radius of 1. But maybe it's worth writing down. Unit circle has a radius of 1. And I'm just going to draw that on set of axes again. Right there. And if you want to, you could draw in a triangle so that you could see what it looks like and how it translates. All right, so we've got sine theta, cosine theta, tangent theta. I want you to pause your video for a second and fill in these three values. Pause and fill in. You might be like, oh, there's so many fractions, I don't like it. But remember, we're not scared. 1/2 over 1 is the same as 1/2. Square root 3 over 2 over 1 is the same as square root 3 over 2. The next one gets a little tricky, but it's not so bad. We're going to do a little keep, change, flip. So we keep the numerator. That's the 1/2. We change division to multiplication, and then we flip the bottom fraction. Some of you might know that as copy, change, flip. Keep, change, flip, copy, change, flip, same thing. So the 2's will cancel because they're on top and bottom, and that leaves us with a 1 on top and a square root 3 on the bottom. So there's your first 3. Your next 3 should be even easier. Sine matches with cosecant theta. Cosine matches with secant theta. And tangent matches with cotangent theta. And all we do is take now the purple ones and flip them upside down. So 2 over 1, 2 over square root 3, and square root 3 over 1. And you are done with this skill. Well, learning it at least. Now you gotta go practice. Let's talk about what you could write down in your summary, because there's a lot. So in the summary, we could talk about our 6 trig functions. Okay, list them out. And what they match with. You could talk about S blank blank, C blank blank, T blank blank. Your little phrase to help you remember your first 3 trig functions. You can talk about your quadrants, starting with quadrant 1 going around like a C. You can talk about your bow tie, right? So draw that in. Draw your right angles and your thetas. We could talk about finding the third side of a right triangle. And what you use for that. And last but not least, labeling a triangle. So if theta is here, where's your hypotenuse, your opposite, and your adjacent? Okay, these are the major key concepts from this skill. You got to get them summarized so that you can look back at that when you're working on your practice problems.